use properties of logarithms to expand the logarithmic expression as much as possible, and clean it up if you can. So we have a fraction here, so we can rewrite this fraction as two different logs that are being subtracted. The log of the top minus the log of the denominator. Numerator minus the denominator. The log base 2 of 8, that is a 3, because 3 is the power that makes an 8, 2 into an 8. The square root. The square root is the 1/2 power, and we can take that 1/2 power and move it in front of the log, and that's as far as we can go. Write the equation in its equivalent logarithmic form. So we're going to have the log of something is equal to 3, showcasing that power of 3. Your base will be the 9 that the 3 turns into, 729. Evaluate the expression without using a calculator. You are being asked in this problem here to figure out what power it takes to make an E into what you see here. Okay, so in order to turn an E into an E to the 6, your answer is simply that 6. Find the domain of the logarithmic function. Finding the domain, it's very important that this part of the problem stays positive. It can't be 0, it can't be negative. So what I'm going to do is I'm going to set it equal to 0 and create a graph and find the points where it stays nice and positive. This is factorable. This will be x plus 4, x minus 1. X plus 4 will give us negative 4. X plus minus 1 will give us a 1. Now, we cannot have equal to 0, so these will be open circles, and we'll figure out which area to shade. And I will figure out which area to shade by checking a 0. So I'm going to put a 0 in and make sure it's positive. If it's not, then I will avoid the 0. So 0 squared plus 3 times 0 minus 4 is negative 4. Negative 4 is not positive, so I will avoid 0. I will shade here, and I will shade here. Interval notation, you're looking at negative infinity to negative 4, parentheses, union, 1 to infinity.